Statistics is the study of how you collect, analyze, and draw conclusions from your data sets. It is a huge tool that can bring the future into focus and answer some key questions about your business. So welcome back to the channel and welcome to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is day 42. We are on our seventh course in the data analyst in Python career track on the DataCamp platform. So we hope to complete this career track over the next 100 days. And we are on day 42. That means we are 42% out of 100 days of learning. And we started Introduction to Statistics a couple of live streams ago, definitely 2 days ago, two previous live stream behind, where we're looking at summing statistics. We're also looking at random numbers and probability. We're looking at distribution and central limit theorem and correlation and experimental design. But we are still on the first chapter, which is summary statistics, which we are just getting introduced to what is statistics and the difference between descriptive and inferential statistics, or data type and classification in statistics, or the measure of center, the mean median, mean versus median, and measure of spread, that is quartile, interquartile range, and that is IQ, the lower quartile and the upper quartile, and the interquartile, which is popularly known as IQR. And we're also looking at variance and standard deviation. So we've covered all of that on the couple of live stream back. You definitely just want to go back to the previous two live streams and check out what statistics is all about. So we're just going to continue from where we stopped on that live stream, and we have our data set that we'll be working with on this particular course, which is in the statistics introduction to statistics in Python course. So we have this data set, this dues data set, food consumption data set, and the world happiness data set, which the link will be provided under the description, so you can download these three data sets for this statistics lesson here. If I just open this my Python notebook, this is what we've worked with so far. We've begun some basic statistical analysis from the previous lecture. We just look at the food consumption data sets. We did some basic statistics. We also subset and filtered on some rows. So these are all basic knowledge which we've learned from day one of the previous days of learning Python, which is from the Python basics. So if you're looking to start Python from scratch, I'll encourage you to go to the live stream tab on the channel. You're going to see those Python lessons from day one all the way to day 42, where we learned all about our subsetting, filtering, calling on static columns in Python, and basic analysis prior to this statistical or lesson that we have. So I'm just going to continue from here. So if you want to understand what all we've done so far on this workbook, this notebook, just go to day 40, 39, and probably day 39 and 40, or the previous live where we started introduction to statistics. So I'm just going to continue from here and see what we need to do. So we need to solve these challenges here. So we've covered all these lessons previously. So we just have these two few challenges to solve in this section, and we'll be completing this solving statistics lesson. So then we move to this more distribution and central limit theorem on the next live stream. So we're looking at what we're going to. This is quite much. So we're spending a couple of live streams on this lesson. So let's continue on this quartiles, quantiles, and quintiles calculation. So let's see how we can solve these quartiles, quintiles, and quantiles and quintiles. Sorry about that. I have to look at that on the second note. So quantiles are a great way of summarizing numerical data since they can be used to measure center and spread, as well as to get a sense of where a data point stands in relation to the rest of the data sets. So for example, you may want to give a discount to the 10% most active users on a website. So in this exercise, you will calculate quartiles, quintiles, and deciles. We split up a data set into four. Quartiles is 4, quintiles is 5, and decile, like decagon, that is 10. So quartile, quarter. We're all familiar with quartiles, which is 4, breaking something into 4 parts. So both pandas as PD and NumPy as NP are loaded and food consumption is available. So the food consumption data set is also loaded here. So we actually loaded the food consumption data set all the way down here. Let me just run this whole line of code again. So we are back here. So we use this food consumption data set to answer key questions from our data set here. I just go ahead and call on the food consumption data set one more time, just below here. So you can calculate this quartiles, quintiles, and deciles calculation. So this is what the food consumption data set looks like. You can see, but it is quite a number of rows and columns. If you look at it, is over 1,000 rows, with over 1,400 rows of data and 5 columns actually. So this is the number of rows here. I'm just showing the few rows in this line of code up here. So we have the country, the food category, the consumption, and the CEO emission. This is like a food consumption data set, just giving us about information, the consumption of food and various category of food in different countries of the world. Okay, so in Argentina, the poultry, beef, and lamb good consumption and the CO2 emission. So that's what this data set is giving us information on. So if I go back to the instruction, so it says calculate the quartiles of the CO2 emission column of food consumption. So to do that, I have to subset and select only the CO2 emission column and calculate whatever I want to calculate there. I'm just looking at a formula to do that, the line of code to help me with that. So that is on where we learned about measure of spread, variance and standard deviation, and actually measure of spread. So you say we should calculate the quartiles. So we're going to use for you to use statistical work with statistical analysis in Python. You are going to use NumPy data frame, this data frame, to work with the data set. So we've imported the data, the libraries for that all the way from the beginning here. You can see. So this allows us to work with the data set easily. So since we want to calculate the quartiles, we're going to say so I'm going to say NP, and which is this NumPy library dot quartiles, right? Dot quartiles. Let me just zoom in on this. That's too much. This is better. So to mean the quartiles, I'm going to call on the food consumption column. So open bracket also. Open a bracket. So I'm going to call on this food consumption data frame. Then the column we want is the CO2 emission column there. We want to select this particular column here. So the food consumption data frame, but we want to work with this. Our analysis will be on this column. So I'm going to subset and select that column only. Subset the column. And what I want to calculate is quartiles. So quartile is similar to mean. So I'm taking a look at my line of code there. Just So contours is similar to mean, while quartiles, let's see. Let's just call our NP quartile and see if we make any mistake or not. Let's run the code and get help. Oh, NumPy has no attribute quartiles. It's supposed to be quartile or quartiles? Quartiles. Okay, let's see. Okay, let's get help on the error. We are told to calculate the quartiles. So to calculate the quartile, are we going to be using quantiles? Oh, okay. I think I've seen my mistake there. The problem is that you're trying to use np quartile, but there's no such function in the NumPy library. The correct function to calculate the quartiles is np quantile. Oh, you see my mistake, it is quantile. Even though I'm trying to calculate the quartiles, I have to use this function called quantiles. Okay, so that was my mistake there. So I'm supposed to change it to quantile. Let us see. Hmm. Okay, we are still running into an error. So I need to specify 0.5 there. I know I need to specify the 0.5 what I want. Okay. The error message indicates that np quantile function is missing a required position argument called q. So I need to specify once it's not calculate the quartiles, that should be 0.5. Let's see. Let's see. Sometimes you run into an error over and over again. So the q part of the function is comma 0.5. Let's see. See my results. It's not 16.5. Let's submit and see first. Oh, okay. Hmm. So this I'm missing something here. You need to calculate the quartiles. Will the quartile be 0.5 or 0.4? Oh, let's take a step back. Let's get help on the error. Oh, this sounds calculates. That's I'm using 0.5, which is the mean. Okay, import num for example. So you say, have you tried using np quantile function? Make sure you specify the quantiles you want to calculate, such as 25%, 5%, or 75%. Example, I'm not calculating all of the quantiles. Oh, okay, I see my mistake there. Hold up. Even as such, I only want to calculate one. This says calculate the quartiles of CO2 emission. So the quartiles should be okay. Let's see. I'm getting this result for quartiles. I'm still getting an error there. Okay, so this line part of the code, I'm missing something. Uh-oh, this is not fair. Okay, let me grab all of this. It's going to show me different results. Which is the quartile, interquartile range, and upper quartile. Let's see. Oh, we are going to so many errors today. No problem. Mhm. I'm getting same result. But why am I getting an error this time around? Ah, come on. Not today. So it's normal. Let's see. Hmm. Okay. Mm. Have you tried using NP quantile? I'm using the correct function, quantile, to calculate the CO2 emission. Make sure to specify the quantiles you want to calculate. Okay. Let's see. Okay, I think I've used 0.25. Let me now use let me make use of this 0.75, 25%. Come on. Why are you running into so many errors today? Uh, mm. I don't want to look at the answer yet. I'm going to give it every try every try I've got. Mm. So in this exercise, you calculate the quartiles, quintiles. The first instruction is to calculate the quartiles or CO2 emission. The next one is the quantiles. This is the 11 quantiles of CO2 emission that split up data into 10 pieces, which is the decimals. This fits into 5 pieces, which is the quintiles. So this quartile split into 4 pieces. Quartile split into 4 pieces. So how am I getting an error? 4 pieces. Oh, okay. I think I'm seeing my mistake. Let's give this a shot again. Let's see. Okay. Start with a 0 there. Oh, not good. Okay. I'm missing a 1 here. Oh, sometimes print NP quantile, food consumption, CO2 emission, 0.5. We're actually saying the same thing though. Voila. So you can see 0.5. Oh, that was a mistake there. So when you asked to calculate the quartiles, so quartiles split into how many parts? Okay, let me just try to troubleshoot this. So I'm supposed to add 0, 1, 2, 3, 4. 0, 1, 2. Will you say 0, 1, 2, 3, 4 like that? But that's interesting though. But I need to understand. Okay, let me just troubleshoot this real quick. Let me just troubleshoot this real quick. So we've gotten the results. If I try to copy this and paste this here, let's give it a shot in my Jupyter notebook here. Calculate the quartiles of CO2 emission column. So quartiles split into how many parts? Probably 4 parts or 5 parts. You can see it's split into how many parts? 1, 2, 3, 4. So quartiles divide a data set into 4 equal parts. So we wanted to split we needed to calculate was the quartile. We divide the data set rather, this CO2 column into four equal parts. So helping you to understand the distribution of data. When you calculate quartiles for the CO2 emission column in your data set, you are determining specific values that split the data into 25% segments. Hold on a minute there. So the quartiles we need to calculate was uh, the calculation in statistics that divide the data set into four equal parts. So we just need to divide this column into four equal parts using this line of code here. So we need to specify 0, 1, 2, 3, 4. Okay. So interesting. So we need to learn more on that. So let's submit that. So calculate the six quantiles that split up the data set into five pieces. Quintiles of the food consumption column of the CO2 emission column of food consumption. So now we need to calculate that split the data set into five pieces, which is quintiles, but it is called six quantiles. Hmm, okay, how do you do that? Oh, I'm going back there. No, let's come back here. So definitely we'll be using the same line of code. We just need to specify how we want to calculate. Oh, hold up. Let me just go back here a little bit. NP quantile. Now we need to calculate to divide the code into six equal parts. Okay, now let's see how to do that. So this now says six quarters is divide the data into five equal parts, but you need six quintal values, including 0%. So we need six quintal values, including 0%. That is going to be 0, so this is going to be 0, 0, 20, 40, 60, 80, 100. So this is what it means to calculate it. Quintals, it is quintals. So to do that, you're going to say percentile. It's going to be percentile. So I'm calculate the percentage. Percentile. Let's see. So you calculate it anyhow. Let's use numpy. This is for pandas data frame. So we're using numpy here. So this is for numpy. You can also use pandas to calculate it. Dot quantile. Okay. Let's go on the line of code and see. Voila. So that's correct. So that's how you determine and split the data set into five equal tile. But you're going to be needing six quantiles. So this is for let me just add this notes here. Oh, that's long. So, quintiles. So, quintiles divide the data into five equal parts, but you are going to need six quintile values, including 0% and 100%. So, these quintiles represent 20%, 40%, 60%, and 80 percentiles of this column. What about for quartiles? For quartiles, so quartiles divide the data set into four equal parts. So, quartiles divide your data set into four equal parts. Because that is interesting. Now, let's see the last one. So, I've not run this line of code. So, this is calculation of this quintiles, which is just showing out the 20%, 40%, 60%, 80%, and 100% part of the whole data sets. So, let's calculate the 11 quintiles of CO2 emission. Oh, the deciles of CO2 emissions, CO2 emissions rather. So let's see. So how do you calculate this? The deciles. So deciles divide the data into 10 equal parts. So from the word decagon or decimal, so 10 equal parts, meaning you need 11 quintiles, but you're going to be needing 11 quintiles, including 0% and 100%. So the quintile, that is going to be 10%. So this time around, since it is deciles, it's going to be 10%, 0%, 10%, 20%, and so on and so forth like that. So let's see the line of code to solve that. Let me just copy this from here. I don't even need to add print here. Oh, sorry. So I'm not going to copy this like this and just paste it here. So we need is 0%. So NP percent of food consumption. Then we're going to add NP range. Let's see. Let's see it here. So from here, we're going to change this part of the code here. So NP range 0, 1, 10, 10. Let's see. Oh, voila. Is that correct? Great. So these are some high quality contours. While calculating more contours give you a more detailed look at the data, it also produces more numbers, making the summary more difficult to quickly understand. That's true, because they're kind of scary and not easy to understand sometimes. So let's see it here. So this is what deciles means. You're dividing the data set into 10 equal parts. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that that is way, way too much. From zero, rather though. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from 0 to what? 10, 10 equal parts. Ooh. So this cells divide the data into 10 equal parts, meaning you need 11 quintiles, including 0% and 100%. You see? So that's just a quick note there for me to remember what that code is doing. So let's solve this last part of the challenge, which is this finding outliers using interquartile, which is IQR, which is this last part here. So that'll be the end of the live stream for today. So outliers can have a big effect on statistics like mean, as well as statistics that rely on the mean, such as variance and standard deviation. So interquartile range or IQR is another way of measuring spread that's less influenced by outliers. So interquartile range is also often used to find outliers. So if a value is less than Q1 minus 5 times IQL or greater than Q3 plus 1.5 times IQL, it is considered as an outlier. In fact, this is how the length of the whiskers in a matplotlib box plots are calculated. Oh, so in this exercise, you calculate IQL and use it to find some outliers. Pandas as 3D and NumPy as NP are loaded and the food consumption is available. Okay, so these are some highly technical stuff. They're not really that technical, but let's see. It says calculate the total CO2 emission per country by grouping by country and taking the sum of CO2 emission. Store the resulting data frame as emissions by country. Okay, so we need to group by country. Let's see. So I'm going to calculate total CO2 emission per country. So we are going to be using group by clause here. So we want to calculate CO2 emission for each country by country. Let's see. So it's going to be food consumption, food underscore consumption dot group by dot group by. So I want to group by the country column, but I want to calculate the CO2 emission for the country. So emission by country, food consumption dot group. I'm missing a P there. Group by country. Then the column. I want to use this. Okay, let me just go by country first. Let's copy this line of code and see what we have here. So you understand what we are doing to this data set now. I want this line of code. If I now call on this emission by country for you to see what just happened. Oh, okay. So I need to mention the calculation I want to calculate on it. So now let's complete it. I pick on the CO2 column, this CO2 emission column. Then I add the aggregation to it. So if you're using group by, normally in Excel or definitely in SQL, if you're using a group by clause, you have to perform a calculation on the group by clause. So the calculation must follow. Now let's see. Now do you see now? So it's grouping, it's calculating this CO2 emission column. It's summing it up by the country. So that's what it is doing there. Okay, but I can make it easier. Let's go ahead. Let me just do dot add. Let's make use of that. Dot add. Okay. So we have same thing here. Albania, Algeria, Angola, Argentina, Albania. As you can see, same calculation. Okay. Now compute the first and third quartiles of emission by country and store this as Q1. So compute the first and third quartiles as Q1 and Q3. Since we have to compute the first and third quartiles, let's see how to do that. So the first quartile is going to be NP percentile. I think the first quartile is 25%, while the third quartile is 75%. It's going to be NP dot percentile Let's see. NP percentile, open brackets, emissions by country. Then same thing, NP quartile emission by country. And this will be 75%. Oh, hold on a minute. My antivirus is giving me some error there. I just have to get rid of that. Okay, we are back. So this is going to be 75%, which is the third quartile. So that is Q1 and Q3. Now let's calculate the interquartile range of emission by country and store it as IQL. So you are going to subtract the third quartile from the first quartile. So the first quartile, which is the Q3, so we're going to say Q3 minus Q1. So that should give us our answer. Now let's see that are we correct? Hold up. Let's submit and see. Oh, good, we got that. So that's how to calculate that. So let's move up here. Now let me do the same thing right here. So we're not going to get any results with it, but the code works fine. By country. If I go back here, let me just do same thing here. So that's that. Now let's calculate the interquartile range again here. Ooh. Oh, that is a line of that is a block of code, not a calculate. So that is a notes. Okay. Now let's move. Say calculate lower and upper cutoffs for outliers of emission by country and store this as lower and upper. Calculate the lower and upper cutoffs. So you say calculate the lower and upper cutoffs for outliers. Lower and upper cutoffs. Lower and upper cutoff still refers to IQL, Q1, and Q2. Okay. So lower and upper cutoff will now be this IQ if value is less than Q1 minus 1.5 times IQL or greater than Q3 plus 1.5 times IQL. So that's how we calculate that. So that should be Q1 minus 1.5 multiplied by the IQL. Where is multiplication? That should be star. Multiplied by IQL. Then this will be Q3. Q3 plus 1.5 1.5, then multiply by the IQL. IQL. Let's see that. Let's run the line of code. So that calculation is correct because I was running it alone. If I run this now, that should be our lower and upper cutoffs for outliers. So if I now submit this, let's see. Voila. Now subset emissions by country to get countries with a total emission greater than the upper cutoffs or a total emission less than the lower cutoffs. Now I want to use all this calculation to figure out the outliers in this particular column, in this CO2 emission column. So the outliers will be lower than the upper column. Let me look at that again. To get country where the total emission greater than the upper, so the outliers will be greater than the upper cutoffs, these upper cutoffs, or lesser than the lower cutoffs for us to get this calculation. Let's see that. Let's subset the data set there. So we're just going to filter that column to results lower than this cutoffs there, and those that are higher than. So those are our outliers in that line of code. Interesting. So it's going to be like this. Emissions by country. This emissions by country data frame that we have created since from here. This emissions by country. Open brackets. Square brackets. So emissions by country greater than the upper cutoff. Then I'm going to use a slash there. Looking for my slash. Nope. Yeah. Then come on. Open brackets. Emissions by country are lesser than the lower cutoff. So that's to give us our outliers in those scenarios. Now let's run the line of code. Ooh. So let's see where we are getting an error. So it's just about emission by country. Emissions by country. Okay, I'm getting there. Oh, I have to wrap this in brackets. I'm missing a bracket there. Emissions by country, lower emission by country. So my lower is supposed to come before my upper. Lesser than, lesser. Oh, I'm using both less than in those scenarios. So that was my mistake there. So emissions by country, lower, lesser than the lower cutoff. The emissions by country greater than the upper cutoffs. Greater than the upper cutoff. Upper there. So this is supposed to be in brackets, brackets. So it's going to subset the data set. Emissions lower where emissions upper. Voila, look at those countries. So the country is even Argentina. That's Argentina alone. Let me see it here also. So let's see. If I call on outliers now, outliers, see the only result. So the outlier in our data set is Argentina, which is the emission for Argentina is lower than this our lower cutoff, and this is greater than our upper cutoffs. Interesting. So that's how you calculate outliers. Ooh, nice one. So outstanding outlier detection. It looks like Argentina has a substantially higher amount of CO2 emissions per person than other countries in the world. That's nice. Oh, so that is a good challenge there. So we are moving to this calculation, the next chapter, which is random numbers probability from day 43. So I'll see you on the next day, which is tomorrow, as we continue this random numbers and probability. So what are chances? So that'll be the end of the live stream for today. If you enjoyed this statistical challenge and this learning journey of Python with me, do well to support the channel by giving the video a thumbs up, hit that subscribe button, and I'll see you on the next video on the channel. Have a wonderful rest of the day. Let's get back to work. Bye.